This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations for the Satellite Book Club Seminar Series. This is session number 39. We got a great panel discussion today on situations where the WFO radar was unavailable. Joining us for the panel today is Christopher White from the Huntsville Weather Forecast Office, Stefan Bita, Caitlin Rutt, and Douglas Weber from Amarillo. My understanding is Douglas might be under the weather today, not able to be with us for the panel. Our facilitator is Chad Gravel, Techniques Development Meteorologist at Southern Region Headquarters. Just a few reminders before we get started. This session is being recorded. We'll have opportunity for Q&A after the presentation. So please post your questions in the chat and we'll field them in the order they were asked. Also, click on the View Everyone tab in the middle of your GoToMeeting screen and select the active camera or View Who's Talking option for the Q&A section because we do have multiple presenters today. We are looking for future presenters, so if you have an application to share with the field, please get in touch with us. We'd love to have you. And the training team can help create training materials that may be unavailable, or maybe you just need help finding them. Brian Mata has information and answers to your questions regarding that. As always, thank you to our Tower S team, particularly Rashad Bowman, Office of Chief Learning Officer, GOZAR, and JPSS program for organizing the Satellite Book Club. And I'd like to thank all of you for being with us. We're routinely seeing around 100 participants, which is really great. I also hope everybody is staying well and looking forward to spring. Without further ado, I'd like to introduce our panel members. I'll go through each panelist. First, we have Dr. Stefan Bita, the Science Operations Officer at the National Weather Service Amarillo since July 2015 and was previously meteorologist for 2 years at Pendleton, Oregon. Prior to joining the NWS, he worked at the Air Force 25th Operational Weather Squadron as a Science Operations Officer and later Director of Training Operations from 2009 to 2013. Also joining us from the Huntsville Forecast Office is Christopher White, serving in the role of Applications Integration Meteorologist, a joint position between the Weather Service and NASA Sport since August 2011. Before entering the role, he was an intern at Duluth, Minnesota in March 2006. And last but not least today, Caitlin Rutt has been a forecaster for just under 3 years at NWS in Amarillo. She's a satellite focal point for the office and tries to bring the use of satellite products to operations every day. Also a previous satellite liaison. Doug's out today, but if he had been here, he's a senior forecaster in Amarillo as well. So without further ado, let me turn it over. Welcome to the Satellite Book Club.
Okay, thanks. Do y'all want me to go ahead and start? This is Chris.
Yeah, please, Chris. Thank you.
Okay, all right. Okay, so yeah, so what I'm going to talk about here briefly, and I'm not doing a deep dive into any situation where we lost radar. I'm just going to mention a few events, basically what happened, and then I'm going to go into some products that are out there that are satellite based that at least help to address an issue with radar beam blockage situations and lack of radar situations. And so I'll mention just a few of those products quickly. So I'll just go ahead and get started here. By the way, this is a picture, this is after the April 27/11 event. And this was not our radar. This was a local media radar that was directly hit by a tornado. So there you see where the radar should have been sitting on top of this tower. So one of the more recent events we had where radar was lost was 11 January 2020. The radar went down during a line of convection that was crossing the area during the morning, and we did have more severe convection expected in the afternoon. Right around the time the radar went down here, we had just had a couple of wind damaging reports. So, and I actually wasn't working this event. This is just last year. I was at AMS in Boston, but anyway, so you can see here the line has moved across. We've had a couple of damaging wind reports. Our primary radars were noted here, KHTX, and then kind of a primary/secondary radar, KGWX. So I got on a AWIPS cloud session with Lee and Kashad here just the other day, and we looked at some satellite imagery from this event when right around the time the radar went down. So here's just standard clean IR window channel. Notice that there's not really any features you can necessarily make out in that, at least with respect to that leading line of convection. And this is likely because this was relatively shallow convection and it was below the cirrus canopy. So the cirrus canopy was kind of blocking what was going on beneath at the time. We did also just look at the day cloud convection RGB and looking to see if there was a little bit more structure. And again, we might have expected to have seen that. You can see some of the bubbly so-called clouds to the west, but at least right underneath our line of convection, it's hard to make out any features which directly tell you that there's some sort of a convective processes at least going on there. And again, it's because the cirrus was covering that area at the time. So forecasters at that time mainly switched to, of course, backup radars. We still had the KGWX radar down here, with also heavy use of satellite, GLM, the geostationary lightning mapper, especially east of the I-65 corridor. They were using some of these satellite-derived products. One of the issues with KGWX, so here's roughly where this I-65 corridor is denoted by this yellow line. The closest it gets to our area at the lowest beam slice along the interstate, there's about 7,700 feet above ground level. And then when you're all the way up at the northern end of our area here, it's about 12,000 feet. So, you can imagine what forecasters might be dealing with in that situation. They had essentially no radar below those levels because OHX, Atlanta, BMX are all close to this or a little bit higher depending on where you are in the area. And then when the radar did come back up a little bit later that afternoon, this is 1932 Zulu. Notice it came up just past the Huntsville area and our main population corridor. There had already been 3 tornadoes that had occurred once the radar came back up. So they were dealing with that as well, trying to issue tornado warnings without our best radar available there. So another event was 22nd of June, 2018. So this was the loss of radar with a severe thunderstorm warning ongoing here. This is in southern middle Tennessee. We have a few counties that we're responsible for here. So you can imagine, going from this essentially to this, at least if you were just looking at the HTX radar. So then they switched, of course, to some backup radars. The national radars are closest to this particular storm, but even at its lowest slice, it's about 7,000 feet AGL right here with this storm. So that can be an issue, especially when you're trying to assess what's going on in the lower parts of the storm with respects to wind damage or tornadoes. So another big event where we lost radars. This was 27th of April 2011 during the super outbreak. I was actually working this event on radar much of the day along with some colleagues. So this was the last view available from the HTX radar at this time. So at 2211, there was our last view from that radar. All these T's denote where we had tornado warnings ongoing at the time. We did also lose, and it's not mentioned in here or specifically indicated, but we did also use a local research radar called ARMOR. So things became a little challenging. We then very quickly had to switch to backup radars. We were using the GWX radar down here, but also using just Nashville's radar for Tennessee counties, Birmingham radar for our southeastern areas, and Atlanta radar a little bit for the east and northeast. And so we were kind of quickly monitoring a few different radars. But of course, in addition, we were using a few other products, which I'll get into in a moment. So here's a 4-panel showing, at least at that moment that we lost the Huntsville radar, what it looked like per the GWX radar in these bottom 2 panels, and then the high top radar in these top 2 panels. So we went from essentially this view to something like this. So Now I've just switched out the Huntsville at the top for the Nashville radar, just as an example. Now, of course, in this situation, we were dealing not with a line of thunderstorms or low top convection or QLCS, which we often do in our area, but these were, very large supercells. And so it was still relatively easy in this event working even with backup radars because it was fairly obvious what was going on in that day. And we had a relatively homogeneous boundary layer environment across the area. So anywhere, essentially, we had supercells and we had indications of strong rotation aloft, those storms were getting tornado warnings. I mean, that was the general methodology that day. So also, we did use, of course, satellite and LMA data. I'll show you just a little bit of that. So satellite, here's just at least one depiction of what the satellite looked like about at the moment that our radar went down. And of course, you can see supercellular structures and overshooting tops and that kind of a thing. And so that also helped to some extent the warning making decision processes on that day. With regards to total lightning data, so we used to be privy to a lightning mapping array here in North Alabama. It's been an integral part of our operation since 2003, and we were using the data that day. But even there, the ground-based lightning network did suffer from tornado damage, and it was right around the time that we lost the radar. So we lost the radar about 2211 Z, and notice here it was about 2230 Z when we started to get degradation in the LMA network itself. And you can see this happening right around the time that cells were moving across. This is Madison County here where Huntsville is. And notice that values decreased off to the northeast. And this wasn't necessarily because of lower amounts of lightning, it was because of some of the loss of sensors that day with the network that were affected or hit directly by tornadoes. So I did just want to briefly mention some products that are currently out there that can help address at least lack of radar situations. Granted, these are not products that you would necessarily use for convective warning situations, but otherwise just precipitation or snowfall kind of situations. So the first one I just wanted to mention was the NESDIS Snowfall Rate Product. So this does use passive microwave from a suite of 10 different satellite instruments to derive snowfall rates. This particular one I'm showing you here is actually a blended product. It's blended with the MRMS precipitation. And there's an algorithm that specifically determines whether or not it's likely snowfall. So all you're seeing here is essentially snowfall. But what happens is, notice that you have the MRMS data, but then you have a swath of polar orbiting data that gets inserted on top of that. And so then you can get a better idea of the true extent of the snowfall across the region because the satellite is looking down from above and can do that. So that's one product that can help address some lack of radar data situations. Again, this isn't a convective, obviously, situation, but still there are, other things than just convection that we have to deal with. So this is obviously a snowfall type of a use. You do get about 20 passes a day or so in the CONUS, and then as you get closer to the poles, you get up to about 60 passes a day. And the latency with this product is just about 6 minutes, so that's pretty good for help with these kind of situations where you have beam blockage, especially as you see here in the West. Here's another situation of the added benefit of this product in southern Alaska. So this is the Anchorage area. You see the Alaska radar here. Notice that then when the NESDIS snowfall rate is included with that, you get really a much better extent of what the snowfall is occurring, at least within the clouds in this area. Another product called NASA IMERG. So this is an integrated multi-satellite retrievals. This is from the GPM network. And this does fuse data from the GPM satellite constellation essentially to generate rain rate retrievals. And this is a precipitation and rain rate product. And this is also available in the AWIPS. And just here's a very recent example of what it might look like, offshore. And I included clouds here for some context. But, there are some pretty significant issues with this product. The main thing being latency. As you see here, it's about 4 hours. So it's not something you'd necessarily use in a rapidly evolving convective situation. And the temporal resolution is about 30 minutes. NESDIS GOES-R QPE, here's another one. This is a different kind of a product. It uses both polar microwave and also GOES and AHI infrared data to estimate rainfall rates and then produce precipitation estimates from that. The current image you actually see here is from the advanced Himawari imager version of this, the IR, because we're looking way out west in the Pacific and the Indian Ocean Basin in Asia. It does have 10-minute temporal resolution, which can be nice. And quite honestly, there may be other groups out there using it, but this is actually a product that's used heavily by the U.S. Drought Monitor for the U.S. affiliated Pacific Islands. And it's used to determine weekly precipitation over some of these islands for the Drought Monitor. So, and it does actually perform best in convective environments. And so I think that's all I had. I probably went over my 5 minutes. I'll go ahead and turn it over to Stefan, and I'll stop sharing my screen here.
All right, Stefan, you and Caitlin can take it away.
All right, can everybody hear me?
Yeah, we can. We can see your radar anyway.
Absolutely. And the reason for showing this is that the situation that we're going to be talking about today from the Amarillo area was concerning the January 9th and 10th winter storm that went across the Texas and Oklahoma panhandles, as well as portion of West Texas. And what I've got shown here is the radar sites that are available to our county warning area. The main one being that we had problems with, of course, was that we had 2 radars down this day. We had the Amarillo radar down for scheduled maintenance, and then the KFDX radar in Eastern New Mexico was also down due to an unscheduled outage. So those are our 2 primary radars that we tend to contend with when we're trying to address winter weather in our area. So what did we do in order to help address not having a local radar during a winter weather event? So one of the things that we approached was that satellite imagery was our primary methodology. We did so with the understanding that water vapor imagery is probably the most likely that we're going to use, among other examples that Chris shared earlier, in order to monitor the progress of that upper low, as well as to get a better sense of where the moist features and the dry features are of that upper low. The second thing that helped us succeed through this event was that we had extensive and frequent review of real-time observations. And so we needed to know where the onset of the snow was occurring, how intense it was from those surface observations, and where the precipitation was ending, because we had no radar to look at. And of those radars that were available to us, they were all overshooting the wintry precipitation. So lots of inquiries were made on social media, Facebook and Twitter, to determine what was going on in our forecast area. And we were constantly on the phone that day. We were reaching out to emergency management. We were reaching out to police officers in the field, and TxDOT and Oklahoma Department of Transportation, because they were all sending out their plows, and sometimes even had webcams on their plows to at least give us a view as to what was going on. And then finally, NWS chat to inquire and obtain that ground truth. This is one of the critical things that we've been using in our office a lot, especially during that event, which helped us work our way through the event. So I'm going to go ahead and hand it off to Caitlin, because she was working the satellite as the snow was moving across the area on a midnight shift.
Thank you, Stefan. You can go to the next slide. Okay, so this is one of the images that we threw out on our social media. Oh, go back one. One more. Yeah. There we go. Okay. And so this was thrown out ahead of the system. Oh, we went back too far. There we go. Ahead of our system that was coming our way. And so basically you can see the low pressure system setting up over the Four Corners region. And then you can kind of pinpoint that this is your dirty IR window, and it gives you an idea of where the system, the best moisture was. You can see the area of enhancement to the east of that low. So you've got your rising and cooler cloud tops, and it's also depicted at the end real quick. And basically that's the enhancement we were watching over the next 24 hours as it approached the mountains in New Mexico, and also the area of better moisture. So I just wanted to give this as like a how we were monitoring ahead of time, because we also didn't have our radar at that point either. So, but obviously we could use Albuquerque's to see where it was coming. So you can go to the next slide, Stefan. So this was kind of in the heart of it. I was actually on the midnight shift during this event, and it kind of started in the evening, but really kind of hit us during that time period of 11 p.m. and on. So I thought it was really interesting to show kind of what the mid-level water vapor analysis was showing. You can see that the low was setting up over south central New Mexico. And you'll see that I'm indicating what's going on with this band. Basically, darker colors are indicating the deeper moisture, moderate snowfall. That was kind of just to let our public know what's going on, since we didn't have those radar updates, to give them the idea of where is the better snowfall rates happening at this time. One thing that I was noticing in the mid-level water vapor was there's this pocket of dry air that would potentially cause a lull in our snowfall, especially in the southern Texas Panhandle, which included Amarillo. And so this was something we were just keeping our eye on, as again, we could look at Lubbock's radar and see, okay, they had a lot of moisture down in their area, but with Amarillo's radar out and then Clovis's radar out, we also had a problem knowing what was coming out of eastern New Mexico into our area. So if you go to the next slide. So that recent one was at 12:30 in the morning. This is now around 6 a.m. So the system's now moved over into the southeast corner of New Mexico, approaching West Texas. And what actually happened was a secondary low kind of formed up in the Oklahoma Panhandle region. And so we started to see the moisture from the original system down near southeast New Mexico coming up north, but then that secondary low was causing the moisture on the south side to get advected over into Oklahoma. So a lot of our northern Texas Panhandle and Oklahoma Panhandle were already done with snowfall by 6 a.m. because we were seeing that this secondary low was keeping that moisture from reaching their areas. A lot of our Texas Panhandle, as you can see below Amarillo, we probably have a row of counties still in our area. So most of it was still in Lubbock's area, and then it was moving east into Oklahoma and also into Fort Worth area. So it was really cool to see this on mid-level water vapor. Obviously, we didn't have our radar. We had ASOS, we had stuff like that, but this was a way to kind of depict a picture of what was going on and to explain it and show it in a way of seeing it. So this is one of the things that helped us a lot, was having the satellite available. We did look at a few other products, but to be honest, during the nighttime hours, you aren't getting that visible satellite. So you can see cloud tops cooling, but you're not getting that structure, just like Chris was talking about. You're not getting that structure of the cloud tops, and so you don't get that kind of bubbly feature to see what's going on, which is more deep convective. You're just kind of getting those brightness temperatures. And so I felt like mid-level water vapor analysis just did the best for showing the overall scale of the event. And I think that is it.
Okay, great. Thanks, Caitlin, Stefan, and Chris. Before we go into Q&A, I thought, because some people have to drop off at the bottom of the hour, I thought we could advertise the next satellite book club. So a week from today, on Thursday, March 11th, and you can see that on our screen, Melissa Huffman, the WCM from the Corpus Christi office, is going to discuss satellite data for communicating tropical cyclone hazards. So again, please, join us next week for that. And then if you have any feedback for the Tower S team about these satellite book club sessions, or just getting satellite products into operations, there are the emails that you need to do that. And they also have an NWS chat room called Tower-S that they monitor, that I don't know if a lot of people use and know about. So make sure that you can get them that way as well. Okay, so I have a question, and I think it's going to lead into, it could lead into a decent discussion. And my question, and I kind of want, here's the order. I'd love to hear Caitlin answer first, then Chris, and then Stefan. And the question has to do with the value of 1 minute satellite imagery. And I was surprised that neither Amarillo or Huntsville mentioned the value of 1 minute data at all. when radar was out, because that's on a time scale obviously quicker than, than you get radar, and it can obviously, it could fill a potential void. And the satellite program in general has, and just communicated the value of that. And I guess the reason why I'm surprised is if it was used or if it had value, I think that, both of you would have mentioned that. So I'm trying to I'm going to give you guys all an opportunity to share your thoughts, because for those of you who don't know that are outside the Weather Service, we have a criteria of calling these mesoscale domain sectors. And no radar, it's lumped in with something else, or a few other things, but it's number 5 priority. So it's really high on the priority list. And I know that 1-minute imagery was available for the 48 hours around this winter storm. It was available for, I think, those couple Chris events as well. So I guess I'd like to hear your thoughts. Caitlin, I'll let you go first and we'll see where it goes, and then Chris and Stefan.
Yeah, so obviously I'm a firm believer in the 1-minute data, but I'll be honest that I use that typically more in a convective scene.
Okay.
I'm pretty sure though, as soon as I arrive on shift, just being the satellite focal for office, I always am checking to see if we're under a meso and letting staff know. So that is something that we do have procedures that we auto load with the 1-minute if it's available. So we do use the 1-minute. I'm not sure it necessarily did us any better during this event necessarily. So I just know that you're right. 1-minute comes in just as fast or faster than radar. So in a sense, you think that it would be, more useful. But in this case, it was, again, hard because it was nighttime for me to pick some of my favorite products that I can see a lot of that detail that the 1-minute can give you. So for me, I had it up, but it wasn't something that it really provided too much extra help.
Yeah, no, that's great. I appreciate that. And I think, and we know that for convective situations, it's obviously king, right? But I'm curious. I'd like maybe, I would encourage maybe you and Stefan to maybe work with maybe a student volunteer or someone like that to kind of maybe look at this case in a postmortem and just confirm, or in some of your winter cases. The Tower S program has a great way where they can go get past data, load it on their cloud instance, and you could be in the Chrome browser looking at a case very, very fast, right? And they will set that up to you just to confirm that there's limited value there. My opinion is it's probably mixed. It depends on the situation. Maybe in a winter, more convective situation, it might be a little more useful. But it might have been good but maybe 5 minutes is good enough, right? I guess it's important to discuss these things because we have, obviously, when radar's down, it's number 5 priority and it trumps a lot of things. So that's why I asked the question. Chris, is there anything you'd like to add? Because you didn't mention that either. And I just want to give you the opportunity to give us your feelings.
There's probably not a whole lot I could add. Do we use the 1-minute data, or do I specifically? Yeah, sure, I have it up. It's, to me, at least, visually, it's sometimes maybe a little difficult to tell cloud evolution at that sort of a time scale, unless it's, perhaps particularly violent or strong. I'm probably more prone, certainly, to use GLM data at the 1-minute resolution, because that that can be important, rather than looking maybe just solely at some sort of visible reflectance or IR. Because that tells you very specifically something about what's going on with the storm kinematics and its updraft strength. So that's probably all I would add to that.
Okay, Stefan, anything for you that you'd like to add?
Well, this is not the first time we've had a radar down situation. We actually had a 1-month period where we were down in the middle of our summer monsoon season. So A lot of folks did use 1 minute data during that period in order to get an evolution of the storm structure, to try to figure out some of the features that were getting pulled into the storm. And I think Chris made an excellent point there that using GLM is one of the biggest things that we tend to use during those convective scenarios. And I think it comes down to, for a lot of folks, the cadence of the data. How quickly do you need that data? So during a winter storm, I know many folks tend to lean on the 5 minute data and the regular data a bit more, just because really the evolution of things on a minute by minute basis is not as critical unless there are convective elements involved. At which case, then folks I've seen in our office turn to that a lot more to try to resolve some of those convective snow banding features, because that is where I see our folks, and I see the value in that, in those situations where rapid evolution of snow squalls or thunder snow situations is extremely critical in getting the message out to our partners, as opposed to a rather slower evolving system you already know is more stratiform and type of precipitation. It's already going at a pretty steady snow rate versus those periods where the snow rate is going to suddenly increase to you 2 to 3 inches per hour in a 5 minute time span because you have a snow squall moving across. So those are my thoughts.
Yeah, which is good information, obviously, to see, right? I think so. There's a couple of chats about this. I'll just try to, Jared Klein talks about the benefit of, the MDS data, I believe, with the snow squall, event, which like Stephanie talked about. And Scott Lindstrom also, mentioned you had a question, and we just don't know. Obviously, we can't answer that one, Scott, because it wasn't maybe utilized as much. But I think this is an important, it's important going forward for Scott and others, like on the Sims blog, to if you see these cases, and be on the lookout for the value of 1 minute imagery in snow and winter events. Maybe we need to just have a little more applied training on them, but if there's use there, and when to use it and when to call it, because these are called. I mean, this one was called for 48 hours for the Amarillo one, and it's just it's hard to know how how much it was used, obviously. So, but maybe it's good to have in case things evolve in a different way, that it can get switched. All right, some other questions, and this is open to anyone. It's directed towards Stefan, but anyone, is about MPing data. How do you guys in Amarillo or Huntsville? I'd love to hear both. Do you publicize the MPing data, the app, how important it is to make observations, especially for winter weather, but also for convective weather as well? Anyone comment on that, and if you've done that?
So for this situation, yeah, we did ask the public to try to provide ping data if they could. Probably not as heavily publicized as we would like when it comes to the other situations. I believe not too long before this, there was a little bit of an outage with the MPing data that occurred, so we hadn't yet respun back up everything with regards to the social media campaign there. So I'll let Caitlin comment, and then Chris as well.
Yeah, I'm with Stefan. I mean, we get it in on our GR, and I personally have not advertised, so I can't speak on that behalf for office, but I know that was a huge help. I mean, just in general, any kind of reports that evening were any kind of help. So anytime the public has some sort of way to give us a heads up, even if it may not be the most accurate, it just gives us an idea, even ongoing snow or the onset of it, or etc.
Chris, anything to add?
Well, just as far as, reports goes, snow here in Huntsville, it's not a big thing with us, but we did have some recent snow events. But just in general, as far as loss of radar, one of the forecasters here mentioned to me that, it's important to maybe mention on social media when we have radar down situations, and that
Okay,
the
cool.
weather reports then become even more crucial, and kind of reminding our spotters that we need them because we may not be looking very low in the atmosphere, and so those reports become even more important in those times.
Yeah, absolutely. Caitlin, this one, I think this is a good one for you. How were the social media posts using water vapor imagery received? Because, generally, or a lot of times they have radar data on them, kind of when you're in the event. And it sounds like maybe if you had the radar, that would have been used. So any comments about that?
Yeah, so obviously if we had radar, we probably would have been using that more like every hour. But I do like to throw in satellite, especially at Amarillo. We love to throw in satellite images a lot. Between Aaron Ward and I both, I know, throw out a lot. So our public really takes to those very well, actually. And the better we can do at explaining what it's showing is the better they understand it. We throw out a ton of times images to show different cloud layers, which ones are high clouds based on RGBs, based on the different colors. You can see different snow. Especially once we've had recent snowfall, we'd like to show those. They love to see the extent of the snowfall, especially in the colors. I know like it looks good when it's just white and stuff, but I think it also takes well whenever it is in like the red color or even that
There's
bright.
an RGB for that, so it's hard to distinguish a white cloud from a white snowfall, right? That's what I
Exactly,
always
which
say.
is
I was like,
why I think that the
there's an
RGB
RGB,
is
so we
best.
might as well use it, right?
Yes, exactly. So we tend to do that, and we'll include some sort of legend, but like the images that I showed, those obviously a lot of people were sleeping at the times that I was sending those, but people take them pretty well. And I try to explain, the darker blues are the higher, deeper moisture. Like I try to say it in terms of something they would understand than saying brightness temperatures or cloud tops, stuff like that, because that may be a little bit over top of what they know knowledge wise. But otherwise, yeah, I think they take pretty well. As far, we've never gotten backlash. We've never gotten a ton of questions on what am I looking at. We've got a lot of, this is so cool, like, they love the colors. So
Yeah, okay, good. Anyone, this is open for anyone. I lost, okay, there we go. For convective situations with no radar, but this could be with or without radar, honestly. What are some of the clues, features in the visible imagery in particular that can potentially help with convective decision-making or warning decisions?
I can talk first. I actually, I've given a few talks on May 7th of 2018, I believe. But at some point here, we had radar, but I was working that day and I noticed that I was able to pick up on cells splitting through the satellite faster, and that was that 1-minute imagery. I mean, it really can help with. You can see an overshooting top. You can see the above anvil cirrus plume. To me, that's a huge indicator that this thing might be intensifying. Couple that with lightning, you obviously compare a lot of those characteristics together to realize that this updraft is intensifying. And you may even know that before the next radar scan comes in. And if you feel comfortable enough, that might be something you can pull a trigger on faster. So if you see the trends of an overshooting top or that above anvil cirrus plume, which is typical in that visible, you could pull the trigger. If you've got a severe out already on a storm, you see it splitting and it's still severe, you may want to consider drawing up a warning and having it ready if satellite's indicating a splitting and you see a secondary updraft forming. So those are things that I typically look for in visible, and I love satellite in severe. Like I think it can give us so many openings with radar to pair together and lightning.
I think
Chris, why
Caitlin,
don't you respond, and then I'm going to ask Stefan a follow-up question.
okay.
I don't know if I really have a whole lot to add to what Caitlin said. I mean, I think it's pretty much the same thing for me. I know there are some, you know, some ways to look at visible to help assess, you know, shear in the environment, and to some extent, and if you see cloud rolls and how the storms are interacting with that, and then taking shear into the environment, the storm environment. But I don't claim to be a big expert on that. But in general, yeah, it's primarily texture. Vivek in here had some interesting comments about noticing splitting cells and that kind of thing that Caitlin
Yeah,
also
but I
mentioned.
talked about that too, and that's maybe a little more common in the plains than it is in the southeast.
Right, yeah, we're dealing with, you know, pretty moist mid and upper level environments a lot of the time, so we don't get to see, unfortunately, a lot of the lower structures or what's going on maybe in the boundary layer. But
So one of the things that Caitlin said, Stefan, was she talked about, you know, this event, I forget what it was, you know, in 2018, or, you know, normally we have radar, right? And the satellite and the lightning and the radar, just as a group, it really refines your conceptual models, and it confirms or, you know, doesn't confirm what your, you know, what your training and your mental model is. But all of these instances where you have all your tools available, right? And you're learning how to use the satellite imagery because it's still new. I mean, I know it's been 5 years, but I got to admit that we're still learning stuff. I know I am on things that I see, especially in 1-minute imagery, and we probably will be for a while. I guess my question is for you is, how important are these case studies, these individual cases, when you have all the tools for to learn from them when you don't have radar, right? I would imagine those are actually so important. So when you don't have radar and you're seeing these things, and you're seeing how the atmosphere is evolving with convection, that it's going to be so much easier to use the lightning and the satellite data together to make warning decisions with no radar. Can you comment on the importance of all of those working together?
Yeah, especially in 2018 when we did have a radar down during our monsoon season, it was critical. It was make or break on a lot of warning decisions, because the Lubbock radar and all of our neighboring radars overshoot the hail core of the storms or the central core itself. So you couldn't really get a good idea as to whether or not a downdraft was about to occur and give a microburst to an area. But you could use the GLM data and your lightning data to realize that your lightning trends are down and they're going down rapidly. So that means you're dropping your hydrometeors, you're dropping the core of your storm, and you're issuing those severe warnings. Another thing is, like you said, satellite data is something that's really new to all of us, so even to this day. So we do have mesoanalysts in our office that are now looking at 1 to 6 hours ahead using the GOES 16, 17 data for the instability parameters or the wind barbs that are coming out of the satellite to see how the convective environment is evolving, and using that as a heads up to the radar operators, or even if there is no radar, to the warning operators as to what could be happening with a specific set of storms as they move into an area, because it's a lot of data now. And so it's really starting to come down to how you triage that situation and use your time wisely to assess a situation.
So here's a follow-up. So that happened in 2018 when you were radarless for a month, basically. We can't sometimes predict catastrophic radar outages, right? I mean, it's very difficult. We hope when it's a planned outage, we try to schedule it right at a time where it's going to not climatologically, you know, a problem. I guess my question to you is, that was 3 years ago. How prepared, like if that month outage happened this convective season 3 years later, would you be more comfortable as Sue of that happening? Based on like 3 years of learning of how to use satellite and lightning, information together for convective threats?
So I would say I'm more comfortable now than we were then on using the GOES 16-17 data. And I think the biggest thing that helped us is Caitlin has created a set of procedures, a baseline set of procedures that allow us to look at the convective environment and the thunderstorms. And we have deployed that across all of our forecasters. And we actually set up education sheets on all of them to show, okay, here's the best situation for using, say, water vapor. Here's the best situation to use satellite and lightning data and how you can drill down that information. I would say now that we're more prepared and we have a better understanding, is it ideal? No, but I think a lot of forecasters are still working through that idea that the satellite data is actually more timely than your radar data is now. That's still a hurdle that even the folks that have been so used to that radar data is still trying to overcome to this day.
Okay, yeah, great. Chris, how do you feel about I mean, because you're kind of like the satellite focal point for Huntsville, right? So, I mean, do you think that the forecast staff would be, well, maybe it would be uneasy, right, if the radar went down for an event or an extended period of time? How do you think they would be more comfortable now than they were maybe a year or two ago?
It's a good question. I think so. I think these things take time because, I think there is a lot of focus on radar, and forecasters go through this extensive course about diagnosing and making decisions off of radar, and it's not there's not much out there about satellite. They don't go through that same type of training that they have to do for I think it's called the RAC course now. It was DLOC when I went through it, but so yeah, I think so. That's kind of my job. The onus is on me to do those kind of things. I like Caitlin's idea and what y'all have done with some of the procedures there. We have some of that too. But there's a lot more that can be done. And when I was a new forecaster, just getting out of DLOC and coming to an office here, where it was a busy convective office, and they had LMA data. It took me probably a couple of years or so before I felt comfortable incorporating that into my warning methodology, because you're just kind of getting used to the radar data itself and making kind of what is an important decision. And so these things can take some time. People differ on their comfortable level with incorporating their comfort in incorporating new data sets into their warning methodology. So
so here's a follow-up.
And training probably needs to focus on that in the future.
Yeah, and this is more of a comment, and any NWS forecasters, please, feel free to throw it in the chat. My question is, I know that time's valuable, right? Would you consider, or have you created almost like a WES type situation where you're given lightning, GLM, ground-based, and satellite imagery, and basically saying, reports, and okay, for the next hour, you're going to be issuing 90 minutes, you're issuing warnings without radar. Have you ever done that, the three of you, and anyone else who wants to answer in the chat? I think this is important information for everybody to hear.
It was funny that you're mentioning that. I was looking it up here. Yes, we did do a radar denial case where we had the radar data not available to our folks for summer convective west cases. And this was in direct response to what happened in 2018. We did that again in 2019 with a data denial case. And I think folks learned quite a bit from that. I'll toss it over to Caitlin because she was involved in that case too, to see how the forecasters became a little bit better acclimated as a result of us doing that.
Yeah, please.
Yeah, I think anytime you can take a case that happened and run through it, and even a year or two later, so your forecasters don't remember it, or even if you utilize a different area as well, locally, it could be, for us using Lubbock's area because it's similar in terrain and everything. But I think it's great to eliminate that radar aspect to see if people would be willing to pull a trigger. How fast could they pull a trigger utilizing the satellite, the lightning, anything else that they can use. And so for us to have the West to be able to do things like that on, and now with the AWIPS in the cloud, it's a great tool to have to test our limits and see our comfortableness with it and see what we're missing. What products do we think that certain people are using that are better? And that's how we kind of get better at this is, well, I use this, or I'm struggling with this, and that's where we find our weaknesses.
Yeah, my guess is like people will be surprised at how good they are, right? I mean, that's just my thought. And I don't think this would be an exercise in like, if the radar's down, this is what you have to do. I think it actually probably would help your radar interrogation and utilizing these tools much better in the future. Chris, do you guys have anything like that at Huntsville? Like a data denial case, or have you guys done any training like that, you and Brian?
No, not to my recollection. I don't think we've done anything like that. It kind of sounds like the old Star Trek Kobayashi
I'm not a Star Trek guy,
Maru
so
scenario. It's like in a way, it's kind of like the unwinnable scenario. Sorry.
Okay.
But anyway, yeah, you take away someone's data, or you take away something, make something very difficult or almost impossible. But no, those kind of things are good ideas, and we have waste cases here obviously that we've had those type of radar down situations, so that would be interesting.
Yeah. So we're coming up to almost an hour here. Here we'll do one more question. Oh yeah, sorry. Someone chimed in?
Yes, Steve Goodman. Question for Chris White. He's still
go
there?
ahead. Yeah.
One thing I may have missed it since I came in perhaps late, but one thing I didn't hear you talk about was the April 27, 28 case when you had the lightning data. And one of the things that Chris Darden had said was once you had the first EF4 tornado, you knew the helicity in the environment was such that if you got a storm to go, you guys were going to issue a warning because you knew you were going to get another EF4. Was that certain? You didn't make mention of that, but that speaks to maybe characterizing the environment when you know you're in a scenario of that type. Maybe rare, but seems like that's helpful.
Yeah, I don't know exactly what all I said, but yeah, in that kind of environment, when the environmental conditions were relatively homogeneous across a good part of the area. We did have a boundary in the northwest, but east of that, everything was sheer, and Cape is high enough such that pretty much anything we had, it was rotating and producing tornadoes that day. So that actually made that, even though we lost radar that day, that made the warning decisions and the methodology a little bit easier, honestly, than a lot of these QLCS cases that we deal with. So.
Yeah, so Chris, and this kind of took place in January 2020, right? Like, from what I remember about that case is that you lost the Huntsville radar, and there was a couple tornado warnings out, and then you were very close to the expiration of a tornado warning within 5 minutes ish, and then there was another lightning jump, and you saw that, I believe, in GLM. And then that gave the warning forecaster confidence to reissue the tornado warning. Isn't that true?
That's my understanding. I wasn't on radar that day, but one of the other forecasters here was, and yes. So yeah, the GLM can be crucial for decisions like that in helping to either initiate or suspend perhaps a warning. It depends on obviously the situation and what kind of severe weather you're dealing with.
Yeah, great. Okay, well, we took an hour, and we're about that time, so I think it's a good time to pass it over to Jordan to wrap us up.
Okay, thank you, Chad, and thank you to all of our panelists. A very engaging discussion, and thank you to the audience for all of your questions. And this is something a topic that we continue to address. I've heard about stories of forecasters having to issue warnings for hail when there's storms well away from their radar and their radar's down. So this is something that continues to come up. I hope you are able to join us next week. And we got Melissa Huffman, warning coordination meteorologist in Corpus Christi, going to be discussing satellite data for communicating tropical cyclone hazards. And one of the great things about satellite is it really portrays the threat for tropical cyclones. People see that imagery, they see that eye, they react to that. So looking forward to Melissa's presentation to the Satellite Book Club next week. Other than that, I really thank everybody for being with us, taking time out of your day, and I hope you join us next week. Until then, stay well, take care. Thanks, everybody.